Python has a lot of built-in functions that are used to perform specific actions. In general, functions are a block of code that only run when it is called. So far, we have used a few of the Python built-in functions. So we used the type function, format, len, range, reverse, int, string, and float. Now, you might be thinking that, well, when I look at the type function, the reason I don't see any block of code. The reason is because this is just the name of that function. Behind the type, behind the name, which is, type function, there is a block of code that allows it to, tell us the type of data once we call this function. Now, there are many more functions in inbuilt or built-in functions in Python that we haven't seen. So we're going to look at some of the other commonly used Python functions. We use the sum function to add up values. Assuming we have a variable, and let's say the variable is a, and let's assign the value of, let's say, 1, 2, 3, 4, and 6 to a. If we want to add up this value or sum up this value, we can use the sum function to do that. All we need to do is we just do, we type the sum of a, and when we run this, it gives us the answer, which is 16. 1 plus 2 is 3. We have 6. We have 10. We have 16. So that's how we use the sum function. Right now we have a as a tuple. We can also use the sum function with a list. I'll create a new variable, or just a new name, and let's assign, and this time around we want to use a list, and now we can say 1, 2, so 1, and if we now choose to find the sum of b, we get 17. Main function is used to find the minimum value within a range of values. I'll create another variable, and let's call the name of this variable c, and we want to have a tuple of, let's say, 23 to, all right. And if we want to find the minimum value of c, all we just need to do is to use the main function. When we run this, we get 0 as the minimum value. And inversely, we can find the maximum value of c. I'm just going to copy this over. And to find the maximum value, we just use the max function. When we run this, we get 123 as the maximum value, which it is. We can also sort our values using the sorted function, and we have the option of either sorting ascending or descending. Right now, let's say we just want to sort we have the values inside of C. To sort that, we just use the sorted function. When we run this, now we see that the values are sorted ascendingly. So we start from 0 to 1123 up to 123. So this is sorted ascendingly. Now, what if we want to sort our values descendingly? Well, we can also do that. We just need to pass an argument, and I'm going to show you how to do that. So we have our sorted function. We have the name of our tuple, and now inside of the parentheses, we want to. So we have reverse, and I'm just going to type this out first. Okay, so let's run this. So now we see that it's been sorted descendingly, starting from 123 down to 0. Now, by default, there is this argument of reverse, and by default, it is set to false. All we need to do is to change that to true, and like I type, you just type reverse equal to true, and when we do that, the values are sorted descendingly. We can use the list function to change a data type from one data type into a list data type. For example, we have the tuple c, and we know that this is a tuple, and we can check that again using the type function. So this tells us it's a tuple. What if we want to change this tuple into a list? We can do that by using the list function. So right now we just pass c inside of parentheses, and now we can see that c is printed out as a list. And we can do the same thing all the way around. Earlier on we tried the tuple. I believe we already used the tuple, or maybe not. Okay, we can definitely use the tuple function as well. I'm just going to type that right here. Let's say this is a tuple function. We can change a list. Let's say we have a list of 1, 2, 3, 4, 5. We can change this into a tuple by simply passing the tuple function. Similarly, we have the dict function to change data into a dictionary. Let's say we have X, and I'm going to write this out first. And we have this in a tuple. We have the name, position, all right, so this is because this is in parentheses, this is sort of how we save the data as a tuple. We can pass the dict function on this, and when we run this, and now let's print X, it prints out as a dictionary. So we've used the dict function to change this data type, which really again would be a tuple just by using parentheses. We have now changed that into a dictionary. Next we have the div mond, and I believe div is divide and mod is modulo, and we've used division and modulo previously, but we can use this function to divide, and it gives us the divisible, the number of times a particular value is divisible by another value, but it also tells us if there is a remainder. So let's say we have div mond of 8, but we want that to be divided by, let's say, 3. If we run this, it tells us 2, because 3 goes into 8 twice, which is 6, and then we have a remainder of 2. If let's say we pass div mond of, let's try something else. Let's say we have 11, and we have 2. We divide that by 2. When we run this, we get 5 and a remainder of 1. So 10 divided by 2 is 5. And well, this is 11, so it goes into 11 5 times, and we have a remainder of 1. Whenever you have a situation or task that is repetitive and has consistent set of logic, you should begin to think of how you can use functions to complete that task. Earlier, we looked at some Python built-in functions. Now let's see how to define a custom function that captures a logic that we want. The syntax to define a function is we start with a def keyword, which means define, and then we have a name for the function. The name which is for the function should describe what the function does. If you think back to some of the functions we used, the upper function that changes a text or a character value into uppercase. We use the lower function, we use the len function. So clearly the name of the function tells us what that function does. Then the next thing we have is the parameters. The parameters are expected input needed for the functions to work. And any input parameter or argument has to be placed inside of this parenthesis. Once we have the parameter, the next thing is the statement. The statement is the block of logic that we want this function to complete. So what exactly do you want this function to do? And then we have return, the keyword return, which is used to return the result of the logic in the statement. Now, the parameters and return are optional, so we don't have to, state a parameter when we define the function, and we also don't have to use the return keyword when we define a function. And we'll try we'll create some functions, but the reason why, sometimes you might just need a function to do something. You don't necessarily need that function to return a specific value or specific output. So, and that's why return is optional, and the same thing for parameters. But let's why don't we quickly define, let's say we want to define a function that add values together. So we start with our keyword def, and then what's the name of the function? Now, because we want a function that add values or numbers, we want to use something, a name that sort of describe what the function does. So for us, let's say we have the name as add, And the next step is, what are the parameters? So we want, let's say we want 3 values to be added together. So let's say we have x, and we have y, and z. So these are the parameters. We have our colon, and when we enter, we have that tab, and now we have to write the statement. So we know that what we want this function to do is to add values together. So we write the statement x plus y plus z. And the name we give here, the parameters x, y, z, really could be anything. It could be, we could have used a, b, c as well. That would work. And let's change that a to c. And now we just say a plus b plus c. So it doesn't really matter what name we use. What really matters is what we're saying. Sorry, this is c. What we want the function to do. So far we have our keyword def, we have the name of our function add, we have our parameters a, b, c, which are, we want values to be entered. And then what do we want this function to do? We want it to add a plus b plus c. And we can actually save this as total. So, once the values are added, that can be saved inside of this variable total. Then the next step would be to use the return. Now, if we want, like I mentioned earlier, in this case, it would make sense that once once this value is summed together, we want to say what that value is. So in this situation, we can then say return total. Okay, and this is all we need to define, and I just run that to define to execute the cell. So the next step would then be to call. If we want to use this function, then we have to call the function, and to call the function, we just use our function name. We have add, and now we have to enter the values for a, b, and c. So let's say we have 2, 4, and 6. So we want a 2 plus 4 plus 6. And now when we execute this, we get 12. I should also say that we don't have to create this variable that I did. We could have just passed use the return keyword right here, and then the expression will be evaluated. And I'm just going to copy this and show you what I mean. So right now, instead of having total equals a plus b plus c, I can just have return. Okay, so essentially we just have this, and then let's save that. So now we can we can call the function, and now let's say we want 5, 5, 5, and when we run that, we get 15. So the only reason I did created this variable is because I wanted the values to be saved inside of total, and then we can just call that. So it really depends on what we're trying to do. Also, there are 2 words that I would like to explain in relation to the function we just created. We know that the parameters are a, b, and c. When we created our function, we have the parameters a, b, and c. Now, once the values 2, 4, and 6, so let's just use a 5, 5, 5. These are called the arguments. So we have the parameters a, b, c, and we have the argument 5, 5, 5. And these are also called positional argument. And the reason it's called positional argument is because the parameters must align with the argument. So we know that this 5, or maybe this is not, let's use 2, 4, 6. So in this situation, a is 2, b is 4, and c is 6. Let's define another function with the parameters of name, age, and gender. So let's do that, and let's just call this data. And we want the parameters name, we want age, and we want gender. Okay. And all we need this function to do is just to return the name, the age, and the gender. All right. So now let's call the function. And let's say the name is Alex 2, and let's say the gender is male. When we run this, it prints out the name, the age, and the gender. So in terms, what I'm trying to refer to in terms of the position is this. Let's say when we call data, and then instead of entering the name first, we have, let's say we have age, and then we have gender. Let's just say female, and let's say the name now is, let's just say Sean. Okay. Now, when we run this, it still works, but then we are getting wrong information because we know that the name is not 14. Now age, we're having age as female, and then we're having gender as Sean. So it's important to note that when we do this, you sort of have to keep the position in mind, and this becomes challenging as the parameters increases. But if it's just like maybe 1 or 2 parameters, then this will be fine. So I just want to point out that when we create a function using positional argument, we have to make sure that the argument that are entered aligns with the parameters. Let's create another function that adds up the total cost of items bought by customers and display of items bought by a customer, and then display the amount which is then presented to the customer as a bill. I'll write out the function first and we'll go through it together. Okay, let's go through this together. We have our keyword def, we have the name of our function as bill, and the parameters are quantity and price. Then what do we want this function to do? We want the function to multiply the quantity with the price, and that's what we have right here. The reason why we are converting the value we get from here into string before saving into total is because of this concatenation. Right now, we know that we cannot concatenate a string value with a numeric value. So in order to print out your total price is, and then concatenate that with this, with a $sign and then with a total, we need to change whatever value we get here into a string data type. So once we execute that, now we can call the function. To call the function, we have our function name, which is bill, and then we enter the argument. So let's say the quantity is 5, and this could be any item. It could be, I don't know, an iPhone, whatever we choose that to be, right? And then the price, let's say it's priced at $2.50, right? And now when we run this, we get your total price is $12.05. Essentially, what this is doing is it multiplies the quantity by the price. And again, what makes this really great as a function is that we don't have to change anything now, going forward. If the quantity of the item changes, or the type of item changes, that will be captured inside of this input. We don't need to do anything with the function again, and this just gives us our result. As mentioned earlier, parameters are optional, which means when we define our function, we don't have to specify any argument or any parameter inside of this parenthesis. Let's define a function and let's call those greetings. And all we want this function to do is just to, say some sort of greetings, and we can just say return. And what we want it to return is, let's just say, hey there. Oh, may I help you today? And that's all we need this function to do. So now when we call this function, it just prints out, hey there, how may I help you today? So we don't have to specify. It all depends on the purpose of the function itself. So earlier we talked about positional argument and how that could be an issue if we have the parameters, if we have a lot of parameters. So if we take a look at this bill function, we know that the argument 5 has to align with quantity, and then price has to align with 2.50. Well, we can solve that problem, of position by using a keyword argument. I'm going to copy this. And let's paste this again. And now when we call, let's call that function again. Now, when we enter the argument, instead of just entering it as a position, we can enter it with a keyword argument. The way we do the keyword argument is by specifying the parameter. So now we can say quantity equals equal, and let's say quantity equal 10, and we can then say price equal, let's say 15. And when we run this, we still get, your total price as $150. So we still get our values, but now instead of just using a position, which is what we have right at just 5 and 2.50, now we are using a keyword argument. So we specify the keyword and then we pass the argument. And like I said, this solves the problem of having to maintain a position, because right now, if I'm going to call this again, and let's say instead of entering quantity first, I enter price. So we say price equal, let's say 10, and then let's say quantity is 2. We still get your total price is $20, because now when Python looks to call this function, it just picks the keyword, it puts price where price, we defined our function right here. So it's just going to pick the keyword and align it to the output that we're requesting here. So this is what we call keyword argument. We can also set a default value within our parameter. So let's say, again, let's use this function. Now, we can choose to set a default value to the price inside of our parameter. That way, when we call the function, we only need to enter the quantity as an argument. And to do that, all we need to do is we have price equal, and what's the default amount? Let's say it's $5, right? Now, let's execute. When we call the function, we only need to specify the quantity. Let's say the quantity is 10. Now, when we run that, we get our total value. So by doing this, we have a default value and we don't have to enter that argument when we call the function. Now, having done this, you should also know that yes, we did set a default value, but if for any reason when we call the function, we choose to enter a value inside, enter an argument, then that overrides the default value. So using the same example, let's say we choose quantity to be, and we can use a keyword argument. So let's say quantity is 10, and we want to use the price. Now, instead of 5, we choose that the price will be 3. When we execute, we get 30, because now that we specify an argument for price, it overrides the default value we set when we created the function. So just something to keep in mind. From the beginning of this course, we have been working with variables. It is important to note that not all variables can be accessed from anywhere within the Python program. The part of a program where a variable is accessible is called its scope. Now, there are two types of variable scopes in Python. We have the global scope and we have local scope. When a variable is defined outside of a function, it has a global scope, which means that the variable can be used anywhere within the Python program. When we declare a variable or define a variable within a function, it has a local scope, which means the value inside the variable cannot be changed or accessed from outside the function. So we have variable x, that's the name of our variable, and we assign the value of 100 to x. We also have three functions that has been defined, f1, f2, and f3. We don't have parameters for the functions, which is fine because we don't have to declare a parameter for our functions. And all we need these functions to do is to print out the value of x. Now, and let's save this first. Now, let's print out f1, f2, and f3 and see what happens. What we see is that f1 prints out as 100, f2 as 100, and f3 as 100. The reason we get this is because x has a global scope. When Python goes to run the first function, it looks for the variable x. It cannot find any variable with the name x, so it has to go outside. It goes outside and finds this global variable x, and all it does is just print out this x. F2 does the same thing and F3 does the same thing. Now let's see what happens when we assign a variable x and then we assign a value, or we define a variable x and we assign the value of 50. And let's do the same thing for f2, and let's say x is 30, and then for f3 we just leave f3 as blank. So let's save this and let's run this again. What we notice now is that f1 prints as 50, f2 prints as 30, and f3 prints as 100. The reason is because we now have a local variable x inside of the first function, so it does not have to go outside to look for a variable x. The same thing with f2, there is a local variable x, it prints that out, but because f3 does not have a local variable, it still has to go outside to find if there is any variable x, and if there is one, it prints that out. Now, let's see what happens is, let's say we delete the global variable x, and let's print out this again. We notice that f3 still prints the value of 100. And the reason is because even though we deleted x, it is still stored within Python's memory. What happens is, let's assign a value for f3, and I'll assign a x, and let's say x is 20. And let's save this, and when we run this, we get the value of 20 for f3, the third function. Now let's see what happens. Let's delete this, and let's save this, and let's run this again. Now we see that f3 prints x as 100. The reason is because, like I said earlier on, the x, the global x, is still stored inside of Python's memory. But the local variable that we created earlier, x, and let's look at f1. So we have x as 50 inside of f1 and x is 30 inside of f2. Once this function runs, Python does not save this value. So this value of 50 is deleted from Python's memory because it's a local variable. However, the global variable is stored within Python's memory. And that's the reason why, even though we initially had a local x, local variable x inside of function 3, once we deleted that, it really just went back to the global variable. Now, if we assign a new value to the global variable, let's say 80, and let's run this, and when we execute this, we can see now that f3 takes on the value of 80, which is the global x. Another thing is that we cannot change the global x, or the values of a global variable, from inside of a local variable. So we cannot say, assign a value of 100 and think that that would change this global variable. When we save this, and let's actually, what we want to do is we want to print x. So let's run this. So what we notice is that, and we can change we can give this a new value. Let's say x equals, let's say 40. Okay. So what we notice is that x, the global variable, is still printed as 80. So if we make any changes to any of the local x variable, it does not affect the global x. Now we can definitely, so a local variable or a function can use a global variable, but we cannot change the value. So let's assume let's change this to y, and let's say y is 100 plus x, and then we want to print y, and we can execute to save the changes. And now when we run this, we see that f1 is 180, and that's because f1 now goes into, within its scope. It sees x, there is no variable x, it goes outside and uses the value, or uses the global x, replaces that with this x, and then prints out 180. So we cannot change a global variable from inside of a function, but we can use the global variable. So one of the benefits of variables inside of a function having a local scope is that you don't have to worry about using the same variable name. if you have to use different functions to complete a task, or within a bunch of codes that you're writing. Now, although I mentioned earlier that we cannot change a global variable inside of a function, if we absolutely want to do that, there is a way around that. And what we need to do is, and I'm just going to use the function too, we need to specify so we type global, and we'll say global x. So we have to indicate that we want to perform some sort of change to the global x, and that's why we write global x. And now we're saying x is 30, and this x will now be the global x. So essentially we are changing the global x to 30. Let's save this, and when we run this now, we notice that now the x, because we're saying print x is now printed as 30. Now F1 is still showing as 180, and I'm just going to run this again. So if you run it again, you now see, I guess it just took some time for that to register. So once you run that again, you can see that the value of x here is also being updated to 30. So yeah, like I said, if we absolutely need to make that change inside, then we can do that as well. We know that we can store multiple elements inside a list, tuple, or dictionary. We have this list X, and inside of the list, we have the elements 1, 2, A, and B. If we want to retrieve a particular element, we can do that using slicing. So let's say we need the first element, that will be index 0. We can retrieve that value by slicing, right? And we can, change the index to 2, and that gives us A. Let's print out X. When we print X, we get the list 1, 2, A, and B. Now, what if we want to print out each of the elements as a separate argument or as a separate value? How do we do that? We can do that by unpacking X, and I'll show you what that looks like. So we still have print X, and to unpack X, all we need to do is include asterisk before X. When we run this, now we get 1, 2, A, B. This is the same as having 1, 2, A, B. So we have the list is now printed as each of these as a separate element on its own. Now let's say, and let's try that with a string as well. So we have, let's say we have A, B, and C. When we print this, we get A, B, and C. Now for us to print this as a separate element, all we need to do is we just add asterisks, and when we print this, now we get A, B, and C. So instead of having just this one string, A, B, and C, we now have A, B, C. And if we want, we can actually specify the separator to be visible, and we just need to type in the keywords. So we have a comma, and then we type in the keyword sep and equal, and what's the separator we want, we can just use a comma. So now we see A, B, and C. Now let's try this with a function. And for that, let's define a function, and let's just call the name of the function. Let's call it my fun. And for this, we just want we want to include parameters, and we want the parameters to be A, B, and C. And all we want this function to do is just to print out A, B, and C. Nothing, just print out A, B, C. Next, let's create a list, and let's call this my list. And for the list, we want the values of, let's say, 1, 2, 3. Okay. Now let's call the function, and we want to call the function on my list. Let's see what happens. When we execute this, we get an error, and the error says missing two required positional arguments B and C. The reason is because although my list has 3 elements, but this is really just one argument. So when we run this function, it's still expecting, so as far as this function is concerned, this list is A, and it's still expecting a value for B and C. Now, watch what happens when we unpack, because we can unpack this now such that 1, 2, 3 becomes separate elements. So when we run this, now we get the function, my function of my list is now 1, 2, 3. So you can see how important and very useful unpacking is. And because you can unpack any iterable data type, it means that it is applicable to list, tuples, and dictionary. Now that we know how to unpack, what about packing values together? Packing is also very useful. Take a look at this function that we have. We define this function, my function, and we enter 3 parameters. What if we don't know the number of values or the parameters that will be entered into this function? Because right now we are restricted by these parameters. We can only enter, once this function is called, we must enter 3 values for this function to work. And like I said, what if we don't know the number of values that will be entered? Imagine, and I'm just going to use perhaps a silly example, but let's say you're inviting your friend over for dinner, right? You invited 10 people, but you really don't know how many of your friends would show up. Well, you hope they all show up, but what if out of the 10 people you invite, only, I don't know, 5 people shows up? Or maybe you invited 5 people and one of your friends or your guests comes with, with another person, a girlfriend or whatever the case may be. So when we're defining a function for, let's say, this party, you sort of want to keep your options open. How do we do that? So I'm going to create a new function and we will go through this together. Okay, so I'm defining a new function. The name of the function is friends. I'm really just using the example I just gave. So we have the function name as friends. And what we have now in parentheses is we have the asterisk, and instead of passing, specific parameters as we did right here, A, B, and C, we're keeping it open. We're just saying names. So we just want whichever of our guests comes in, we're capturing their name. Okay. We have our colon, and now we can use a for loop. So we said for guest. Now this guest is a variable that we are creating in names print guest. So when we call this function, Python, we go into names. Okay, so this function, Python, we go into names. It's going to see whatever the first name that shows up. It saves that name inside of guest, and then it prints out guest. And I'm just gonna, this should be single T, and then it prints out guest, and then it's going to loop around. And then if it sees another name, it's going to save that inside of guest, and it's going to print guest out. So now let's call this function, and let's friends. So let's say the first, let's just say the first guest is Alex, and let's say we have Sean, and we have which other name? Let's say we have Mary, and let's say we have Tim. So now when we run this, we see the list. So you can see how amazing this is, because now we don't have to specify. So using the same example, we invited 10 people. We would have had to specify 10 parameters in that situation, if we're still going by this option. But now by packing, essentially what Python is doing is this: any value that is entered into this function is saved in a tuple. And then this asterisk, you can think of it that then this asterisk kind of separate each of the values. And then the while loop goes, the first name is Alex. It saves, again, it saves inside guest, it prints it out, it loops around, it says another name, Sean, it prints it out, it loops around, it's Mary, it saves inside guest, and then it prints out guest, and it goes on till it prints out all of the values or all of the argument that is entered into this function. Now we can use this for numbers as well, because right now these are strings, but of course we can use it for numbers. And I'm going to write down another function and we will go through it together. Okay, so earlier we created a function that we used to add values together, and that's exactly what we're doing right now, except that we're not specifying the parameters or the total number of arguments that should be entered. So we're defining, we have the name of our function as add, and now we have asterisks, and then we just name, we just give, it's kind of like a placeholder. We name this num, meaning number, but we can use anything. It doesn't really matter. And what we're saying is this, then we say total equals to 0. Because we're trying to add values together. So we're sort of we create a variable total, and we're given a base number, which is 0, right? Then we use the for loop. So we say for number, and this is a variable. So Python, we go into num, right? For number in num. So Python goes into num. The first value it sees, it saves it inside of number, all right? And then we declare and then we're saying that total, which is right now 0, is total plus number. So we are reassigning a new value to total. The initial value is 0. Once we call the function and a number is entered into the function, that number is added to total, and then Python prints out the total. So now let's say let's call the function, and we have add, and let's say we have 1 and 2 and 3. If we now run this, we get 6, because now Python goes, the first value is 1, it saves it inside of total, and then prints that out. The next value is 2, saves it, adds, print it out, and 3, and essentially it adds all of the values. And now, as mentioned earlier, we're not restricted. We don't have to specify the total number of argument that should be entered into this function. So it could be 5, it could be 10, it could be 100. By the way, since you are learning Python and might be looking at other resources, it is common that the package name, right here we used num, but it is quite common that you might notice from other resources that the name used here is, for this parameter is ag. But like I said, you really can use any name, but again, it's quite common that you would see that as ag. And okay, I'm just going to run this, and it's not going to make any difference. Whatever name you choose will be fine. And ag is just the short form for argument. The way we pack and unpack dictionary is slightly different from a list or tuple, because with dictionaries we need a key and values, unlike list and tuples that we simply enter the element. Let's create a menu dictionary. All right, so we have our dictionary menu, and we have the key, breakfast, and then the values for breakfast is egg and bacon. We have lunch, and then we have rice and chicken as the values, and dinner will be mashed potatoes. The next thing I'd like us to do is to create a function, and we will call the function myMenu. And I will just create the function first, and we'll go through it together. All right, let's go through this together. We define a function. The name of the function is myMenu. We have 3 parameters inside of this function: breakfast, lunch, and dinner. And what we're trying to do is to print out a statement. And we're using the placeholder. We used the format function a while back, and that's what we're using right here. So we want to print out breakfast is, and whatever the value, and we will be using the values we created in this dictionary. So the breakfast, whatever value we have in breakfast, we want that to be entered into this placeholder. And then we have, so breakfast is egg and bacon. We have rice and chicken for lunch, and mashed potatoes for dinner. And then we have our format function. We have breakfast as position 1, well, the first position. We have lunch, second position, and then dinner will be the third position. So the next step would be to call our function, which is myMenu. Now we know that this function is expecting 3 parameters, and right now we're trying to insert. We want to call this dictionary inside of this function, and if we would do that, and let's just do that. we get an error and it tells us that there are two missing required position argument, which is lunch and dinner. We've seen this happen before. Because this is a dictionary, how do we unpack this dictionary such that this now becomes three separate elements? And what we need to do is similar this time. Instead of just having one asterisk, now we just have to add two asterisks, and when we run this, now we get breakfast is egg and bacon, we have rice and chicken for lunch, and mashed potatoes for dinner. So now this menu, which is a dictionary, has been broken down into three different elements or three different parameters, which now works for this function. Now you may be wondering, what if we don't want to specify the parameters because we don't know how many arguments will be entered? We can do that by packing keyword argument, and I'll show you what that looks like by defining another function. All right, what do we have here? So we're defining a new function. The name of the function is today's menu. Because we don't want to specify specific parameters as we did up here where we have breakfast, lunch, and dinner, we're using quarks. Quarks is short form for keyword argument. And this is, you can think of this as just a placeholder. So we can really use any word right here. I'm just using this as a placeholder. The most important thing inside of this parenthesis is this two asterisks. Earlier, we used one asterisk when we were defining a function for a tuple, right? When we, that we didn't want to specify the total number of values we're expecting. For a dictionary, we use two asterisks or two stars to perform that function, okay? So then we have our colon. Now we have the for loop. Now, what this for loop is doing is this. We're saying key, value in quarks.items method. So earlier when we initially learned how to create a dictionary, we looked into the items method, and we know that the items method would show the key value pair. So what we're saying is this. Python, we go into this, once we call this function, Python goes into the parentheses. It's expecting a key value pair, which is that's why we have the quarks.item right here. And then it's going to save the key inside of key. It's going to save the value inside of value. And then it prints out the key and the value, right? Now we can call the function today's menu. And we know that this function is expecting a keyword and a value. So what's the keyword? Let's say the keyword is alcohol. And what's the value that we want to assign to alcohol? We can just have this as wine. And let's enter another keyword and argument. And this time we want to say, let's just say drinks. And the drinks would be, we can just give that a value of lemonade. Right? Now, when we execute or call that function, now we see that alcohol has been printed as wine and drinks as lemonade. So now we can have as many keyword and argument as possible without being restricted in any way. Of course, if we want to have a colon in between, alcohol and wine, we can do that in the print statement right here. We can just we can include that right here. And inside we just have a colon. Okay, so there should be a comma. Let's save that. And now when we run this, we get our alcohol as wine and drinks will be lemonade. And like I said, we can add as many keyword and argument as we want. All right, I'd like to say a big congratulations to you. You should be proud of your achievement. You've come a long way. From knowing little or nothing about Python, you now have what it takes to shine, and you have a solid foundation to build on. I would encourage you to not stop here, but pursue the purpose why you chose to learn Python. You can also download your certificate for completing this course. Once again, thanks a lot for taking this course, and if you have any suggestions on how I can improve future courses, your feedback will be highly appreciated. Till we talk again, keep coding in Python.